Shading verification.
Shading of photovoltaic systems, even partial shading of arrays, can be the most important cause of failure to achieve high system performance. You must verify that the shading conditions on the PV system in the field are consistent with those used in the expected performance calculations. The estimated performance calculations will be done either assuming that the minimal shading criterion has been met or based on the specific shading characteristics of each system. The minimal shading criteria is that no obstruction is closer than a distance of twice the height it extends above the PV array. So for example, the vent pipe on the right there, if it is 12 inches tall, it would need to be a minimum of 24 inches from the array. Objects that are subject to this criterion include, but are not limited to, vents, chimneys, mechanical equipment, or any other obstruction on the roof or part of the building, any neighboring terrain, any mature tree at time of the PV installation, any tree that is planted or is planned to be planted on the lot or neighboring lots that is not yet mature, existing or planned neighboring buildings or structures, and any telephone or utility pole that is closer than 30 feet from the nearest point of the array.
Obstructions located north of all points on the array need not be considered as shading obstructions, as any shadow cast will not fall onto the array. When an obstruction is north of some parts of an array but east, south, or west of other parts of the array, the minimal shading criteria shall be determined to the closest point on the array that is west, north, or east of the obstruction. A tolerance of plus or minus 5% will be permissible when determining the height to distance ratio.
In this example, the neighboring residence is the obstruction that we'll be verifying. You will want to measure from the lowest corner of the array, since it is on basically the first story roof, right over the garage there. You're going to measure across and over to the neighboring dwelling. You will need to do this for every sector in which the neighboring dwelling is higher than the lowest point of that array. So there will be several sectors here that you will need to potentially measure, depending on, again, the orientation of the two structures. But you'll measure your distance across and then the distance above the lowest point of the array to get your distance to height ratio. The first step in identifying if the minimal shading criteria has been met is to first identify the shading object, then determine where is south in relationship to that shading object, and third is what is the relationship of the vent to the solar path and the lowest corner of the array. In this example, does the chimney satisfy the 2-to-1 criteria? Based on a visual observation, it does not appear so. However, you would need to take closer measurements to verify that fact. This tree also does not appear to meet the 2-to-1 criteria. In this example photo, you will see that it is currently casting a shadow on the array. However, again, you would need to make measurements to verify this fact.
When a PV installation does not meet the minimal shading criteria, it can still qualify for an incentive and participate in the NSHP program. The shading conditions for each solar system at the site must be accounted for in the expected performance calculation. The FI calculator will produce a table found on the first page of the NSHP FI1 that shows the planned annual solar access for each array. Here is an example of that table from the FI1. You can see this example has 3 arrays. None of them are minimally shaded, and they each have a different annual solar access, 75%, 80%, and 65%. The table will be specific to a particular PV installation. Measurements made with a solar assessment tool are required to ascertain the extent of the shading conditions on the PV system from existing obstructions. For shading from existing and planned or future obstructions, those shading conditions must be verified using a solar assessment tool. This procedure will typically be used by the PV installer, but the HERS rater may not have direct access to the array and, if not, would rely on the adequacy of documentation by the installer to confirm the shading conditions.
This is a picture of what is called a solar pathfinder. It is a dome that is laid on top of a chart with a compass. You would then use a pencil to draw the outline of the neighboring structures. As you can see in this example, there are several tall buildings surrounding it. You would draw this outline around the or on the paper that is underneath this dome to show which buildings would cast shadows on the structure and at what time. You would then need to use the documentation that comes with the Solar Pathfinder to determine what the shading angles are to determine if it meets the 2-to-1 criteria.
And here we have two versions of the Solmetric SunEye. The one on the left is the more recent version, the SunEye 210, and then we have the original one there on the right. It used a PDA, which was kind of what we had at the time, but a little bit older, but they operate on the same principle. They use a fisheye lens that's on the device, and that takes a photograph of the surrounding area. The software within it then calculates the annual solar access based on those obstructions that it sees, and generates those values that you need to input into the FI calculator for the FI1.
At each measurement point, the tool is placed on the PV array, leveled and oriented consistent with the manufacturer's instructions. Once the tool is properly positioned, it will determine the obstructions that cast shade and the month and time of day when shading will occur. The tool will enable these determinations either through the use of a digital photograph or a manual tracing on an angle estimator grid overlay. Measurements shall be made at all the major corners of the array, with no adjacent measurement being more than 40 feet apart. The points of measurement shall be distributed evenly between two major corners if they are more than 40 feet apart. If no obstructions that are closer than 2 times the height are present along the linear edge, then the intermediate measurements along that edge do not need to be made.
Measurements made at each major corner and intermediate point shall be combined into a single data set and converted into an annual solar access percentage to be compared to the solar access entered into the FI calculator. The HERS rater shall ensure that the solar access noted in the FI calculator is no higher than the solar access measured on site.
Here we have an example of a solar array, along with the 9 different locations where you would need to use your solar assessment tool to document the obstructions that may be in that sector.
These results for a point of reference on the array are converted into a format that can be used by the FI calculator, either through software provided by the tool manufacturer or manually. The installer should keep documentation of the shading shown on the tool, the location of the tool on the array, and the shading obstructions that are indicated on the tool for the HERS rater to verify the results.